Alright, so kind of a quick, straightforward lesson on derivatives of exponential and logarithmic functions. I'm just going to not develop the formulas, just going to tell you what the formulas are and give you some examples. So normally I would spend some time discovering what this might be, but the derivative of e to the u is just e to the u du dx. Okay, maybe we'll prove it some other time. Okay, so an example, if I want to know what's the derivative of y equals e to the x, then y prime would be e to the x. So it's the derivative of, its derivative is itself. More complicated example, if I have y equals e to the 3x squared, y prime would be itself, then times the derivative of the exponent, so times 6x. So 6x e to the 3x squared would be the derivative. If you have y equals e to the sine x, y prime would be itself times the derivative of the exponent, which is cosine x. I suppose I could involve a chain rule. So what if it was e to the sine squared x? So the derivative would be itself times the derivative of the exponent. So what is the derivative of sine squared x? So think of it as sine x quantity squared. So the derivative involves chain rule, where this is u. So it's 2u times the derivative of the inside, which is cosine x. So that is the derivative of sine squared x, or sine x quantity squared. So it's times 2 sine x cosine x. You could clean that up. You could even make this sine of 2x. But one way or another, those are all right answers. That's a double angle for sine. So that's a derivative of e to the u. That's our formula. It's one of four. We've got three more to go through here. So derivative of a to the u is equal to itself natural log of its base times du dx. Okay, so again it's itself natural log of the base du dx. Notice if this was e, so a is a constant, some number to a variable exponent. That's the formula here. If it was e to the u, you could still do it that way. It would be e to the u natural log of u, or e. Well, the natural log e is just 1, so that's why this one has a special formula, just because the natural log of e is 1. An example, if I have y equals 3 to the x, then y prime would be itself natural log of its base times the derivative of the exponent, which is just 1. So if it's a number to an x, that's the formula to use. If I have 5 to the x squared, then it is itself times the natural log of its base times the derivative of the exponent, so 2x. And you would just clean that up a little bit. Not much to do. Okay, so that's a to the u. So when you have a base that's a constant and an exponent that's a variable. 2 down. 2 more to go, but then there's a fifth that I might add in here too, because it's kind of a special thing. Alright, derivative of natural log u is 1 over u times du dx. So that's our formula for the derivative of a natural log. So examples, if I have y equals natural log of x, the derivative is just 1 over x times 1, because that's the derivative of x. More complicated, if I have natural log of x cubed, if I wanted to find the derivative, it would be 1 over x cubed times the derivative of u, so that'd be times 3x squared. So the derivative would be 3 over x. Put this on top and then cross off the x squareds. Notice, actually, if you went back up here and used our log properties, if you said that natural log of x cubed is actually 3 natural log x, and then when you find the derivative, the 3 floats, natural log x is just 1 over x, so we get 3 over x. Two ways of doing the same problem. That's about it for natural log. It's just 1 over u times the derivative. Alright. What if we have not a natural log? So it's an log log of u base a. The derivative of log of u base a is equal to 1 over u natural log a on the bottom times du dx. So a lot of times we call that ulna because it's 1 over u ln a. So 1 over u natural log a times du dx. So example, if I have y equals the log of 8, we'll go 8x base 3, the derivative would be 1 over 8x times the natural log of 3 times the derivative of u, so times 8. So the 8's would cross off. I have 1 over x natural log 3. Just to bring back our log properties, we could rewrite this as y equals the log of 8 base 3 plus the log of x base 3. And if we found the derivative, derivative of a constant is derivative of a constant is 0. So the derivative of log of x base 3 is 1 over x natural log 3. So 1 over u natural log of its base times 1. So two ways of doing the same problem, just using logs like properties or just leaving it as is and doing it that way. Okay, I'm going to do one other type of problem, and these are just 1 or 2 examples of each of them. It's going to take some practice for you to get a feel for it. But what if we have y equals x to the x? So this is not an a to the x, because a has to be a constant. So we have a variable to a variable. And anytime we have a variable to a variable, it could be x to the natural log x, it could be y equals x to the sine x. Any of these qualify if you have variables as a base and variable as an exponent. The first thing you have to do is take the natural log of each side. So, and we're trying to find dy dx, or y prime. That's what we're looking for. Okay, so natural log each side, so we have natural log y equals the natural log of x to the x. Then one of our log properties that can go out front, so it's natural log of y equals x natural log x. Now we're ready to find the derivative. So once you get to this point, differentiate, so d dx each side. So derivative of natural log y is 1 over y prime. Derivative of x natural log x is product rule, so x times the derivative of natural log x plus natural log x times the derivative of x. So 1 over y prime equals x over x is 1 plus natural log x. Okay, so we're looking for dy dx or y prime, so we're going to multiply both sides by y. And we have an answer with both x's and y's in it, but we know that y is related to x by y being equal to x to the x. So y prime would be x to the x, 1 plus natural log x. And I don't know if you have to distribute that, that's probably the answer. So anytime you have a variable to a variable, the first thing you want to do is take a natural log of each side and go from there.